Right. So my name is Jurgen Decloedt. I'm a business developer at the remote sensing unit of Vito, and my presentation is about drone-based phenotyping. So unlike the presentation of Corné, a very interesting presentation. Thanks for that, Corné. This presentation is not on operational agriculture, but more focused on R&D focused companies. So first, a small word about Vito. So we are a research institute in Belgium, in Flanders, but we have offices in Belgium, in Middle East, India, and in China. We're about 900 people and have quite a bit of science objectives. I will not go into detail into that. We are a technology-focused research institute, and we use applied technology to accelerate towards a more sustainable world. So this is in the mission statement of Vito for more than 25, 30 years now. And this means that we perform research in a number of domains, mainly in energy, reusable energy materials, recycling of materials, chemistry, health, and remote sensing. And remote sensing, the unit that I obviously work in. And within this domain, we focus quite a bit on agriculture. The usage of remote sensing, and then remote sensing data science for agricultural applications. So we're active in a number of domains, from the part that I will explain today, phenotyping, where we uniquely use or mainly use drones. We also have some solutions that are more oriented towards field-based solutions, operations at operation scale with farmers, and then a number of remote sensing solutions to monitor global or regional trends. So the application or the presentation today is about the phenotyping domain. I will explain a bit in a few slides what phenotyping exactly is and what it means. But before we dive into this, there are in fact two parts in the solution. We believe if you apply drone technology to tackle a specific problem, in this case the phenotyping challenge, there is on the one hand the technology, the software. So we have developed an open platform which we call Mapio. It's a drone-based image analytics workflow where we focus on the whole workflow. So starting from the data acquisition, the drone flight, up to the analytics and the improvements that it can bring for a specific business. So on the drone part, the drone acquisition part, the drone flight part, we partner today with two Flemish companies, being Sidemark and InFlights. So we don't fly ourselves. We don't have any pilots that perform operational flights with our customers by ourselves. We outsource the flights to these two companies, or some of our customers fly themselves or rent a pilot themselves, one that they know and which is suitable for the job. So we help our customers with this part through these two partners mainly. Then we have developed some software to validate the quality of the imagery right after the mission has been flown. You can upload or check the quality of the images on your laptop. Plug in your SD card, then it will run a number of checks on data consistency, overlap, camera settings, and so on to ensure that we get good quality input. So if there are data gaps, for example, it will be flagged so that you can immediately, while still in the field, refly the mission. So the same tool is used to upload the data to our cloud environment. So the solution runs on Amazon, and there we We process the images. So the obvious first step is to stitch everything to an orthomosaic, and then we extract information out of the imagery which is of interest for the phenotyping customers. And we mainly deliver the statistics behind the information, but also visualize the results, the orthomosaic, and I've embedded an AI workflow to train a convolutional neural network to be able to detect objects within the imagery. It can be anything from a flower to a individual plant, leaf spots, or whatever. So the other part of the solution is are the procedures and the standards that one needs to follow to get the most out of the drone images. So that's why we have established what we call the Mapio Academy. So it's in fact the training set of three half days where we train companies that want to start using drones in their operational in an operational setting in the phenotyping domain on how to embed that into the organization. So where we specify a number of roles, what these people need to do, and in the end, how to obtain ideal or the perfect insights from the data. So in a visual that is represented here, I will not go into too much detail because it would take me too long, but I think this already gives a good idea on what it is about. So phenotyping, what is that exactly? So it's in fact we measure the plant environment interaction on the field. So our customers here are mainly companies that breed new plant varieties or create products that they want to test on a field. Typically agrochemical companies, but could also be biocontrol companies. Any company that develops products that can be used in an outdoor arable mainly context. So a typical use case here is a breeding company develops a new cultivar, a new variety, tests it in the lab, in the greenhouse, and then once they're confident enough that they have found a well-performing variety, they put it out in the field in replicas of number of replicas on small plots on a field, and then they start to measure and observe how these varieties perform in real life. So as you understand, the agricultural relevance is highest in this part, but cost is also highest at this stage to perform the phenotyping activities. So typically this job was or is done by an expert in the field. They go out, measure with all kinds of devices you can imagine, with all the drawbacks that come with that. I think that's obvious for everyone by now. And we replace that or these observations drone-based. The big advantages here is that you get objective digital measurements on plant traits, because that's what we measure. Obviously additional data, also multispectral data, like Corné also explained in his previous example, or thermal data, or you can have LiDAR data that you use to measure any specific trait that you're interested in as a breeder. And you get data for all test plots, which is not possible, obviously, if you have to do the measurements manually, and the data is in a consistent way, so you can compare easily between many different data sets. So the value proposition is obviously that we aim to speed up the phenotyping work, so to reduce the time that you need to test varieties in the field, so you can shorten time to market, have a higher breeding success rate, and create better products. Better seeds can be better seeds, but can obviously also be better products, better chemicals or biostimulants or biocontrol products. As you get more data, better insights, better accuracy, and a much more objective assessment of the performance of your products. So some examples to make that a bit more concrete. A very obvious one is plant height. So this is an example in wheat, where we measure the height of the various plots, as this is one of the traits that this breeder is interested in. By drone, by now everybody knows, and you can measure in a very accurate way height of an object, so also of plants. If you can measure a height, you can also measure or detect lodging, and that's what we detect here. So in a number of crops, this is very relevant, and breeders breed for varieties that are very resistant to lodging. And here you can, in an objective way, measure this. This is a very simple example also on, or a variation on the height measurements. Now, to give an idea on the possibilities on what you can measure, this is again in wheat, where we have developed an algorithm to detect or to count the wheat heads and the spikes on various plots. So we count all the individual heads, spikes, and measure the dimensions and measure the decoloration of the spike. So the decoloring of the spike is an indication for the presence of specific fungal diseases in this case. And the example here shows that we train this algorithm and this convolutional neural network to recognize spikes, the wheat heads, but you can also retrain or refine the model by labeling additional features that have been missed by the algorithm, and in such a way continuously improve the output of your algorithm. This methodology is applied in various use cases. I'll have an example later. Here is an example of disease scoring in a strawberry field, where we use a multispectral camera, in this case a multispectral camera from MicaSense, the Red Edge M. And here we use one of the well-known vegetation indices, like Corneille also explained a number of them in his presentation, and found a correlation between these spectral indices and the presence of the disease in the field. Then another example where we use this convolutional neural network is in a seed production environment, where we measure and count the umbels on, in this case, onions, as a proxy for yield, and translate that on the right-hand side of the screen to an index-based map, where we color code the areas that have lowest amount of umbels, or the smallest or the biggest, as you depends on what you want to get out of this data. By also detecting the color of the umbel, you can also get some information on setting of the umbel, which is obviously also interesting in a seed production context. So also there are quite a bit of opportunities for seed companies to use drone imagery in an operational context. And then my last example is one where we use a more classical segmentation, where we, in combination with a neural network, where we first identify in a seed production field the male plants and the female plants to come to a nicking index, and it's in fact where we calculate the chances of pollination. So after we identified the male and the female plants, we measure the flowering intensity and then create a ratio to identify within a radius of X centimeters or meters of a male plant how many female plants are flowering, to give an indication on chances of pollination, and thus an outlook on expected yield as a means to optimize the supply chain of a seed production company, for example. So these, my time is up. I see these are some examples. There are of course many more. The takeaway is, I think that we use this high resolution drone imagery to speed up or to automate and speed up a manual process at the seed breeders' sites, and thus help them improve their bottom line. If you want to know more about this, don't hesitate to contact us, or you can also find some more information on our website, remotesensing.vito.be.